Hello everybody, welcome to your channel Full Stack Developer, the channel that will boost your productivity as a full stack developer. Why you should consider doing TDD? Before we start answering this question, let's look at this picture. Here we see a man guiding his dog with a bone heading home. By analogy, tests are the man with a bone, your code is the dog, and software requirements is home. So tests are leading our software step by step to meet software requirements. So if you want to define TDD, we can say that TDD is writing tests before code. Did you buy it? This is completely wrong. The previous analogy is correct, but the real definition of TDD, according to the author of the book Test-Driven Development, Kent Beck, TDD is a software development process relying on software requirements being converted to test cases incrementally before software is fully developed. Here we emphasize two important things: software requirements and writing tests incrementally. Do you find this a little bit complicated? Let's see together an example. Here we have a specification telling that a product must have a price that can be reduced by a discount percentage. Subscribers have automatically 20% discounts on all products, but discounts are not cumulative. Only the highest discount is applicable. To simplify this, here we have our product that must have a price and optionally a discount. Subscribers, on the other hand, have always 20% off on all products, but the highest discount is applicable. Let's now convert this user story to rules that will be our test cases. Notice here that I will order them by complexity. It means that we should always start with the simplest rule and then go in step by step to the most complicated one. So here the first rule is a product must have a price. The second one is a discount percentage can be applicable on any product. Subscribers have 20% discount on all products. Discounts are not cumulative. And the last one is that only the highest discount is applicable. Here we have our rules ready, and we are going to start following the red-green refactor cycle of TDD. Let's start writing the first test for our first rule. We make sure that the test fails, and then we write the minimal code to make the test pass. In this phase, we don't need to execute all tests because we have only one for now, and then we enter the refactoring phase to improve our code. Let's now start writing the test for the second rule. We make sure that it fails, and then we make it pass. Here we have to make sure that all the previous tests pass also. So let's execute our previous test, and then we enter the refactoring phase for our second test. Finally, let's try to test for the last rule. We make sure that the test fails, we make it pass, and then we make sure that all the previous tests pass also, and then we enter the refactoring phase for the last test. Here, after we finish, we make sure that all the tests pass, and then we can say that our tests cover all our business rules and all the tests pass. Let's now see this in code. So we are among VS Code. Here on the right we have our product with its price, just to give an example, and then here we have our test file with all the rules that we have seen together. So let's start creating the first test. I'm just gonna copy and paste the first rule, and let's imagine that we have a model that will calculate the price for us. So I'm going to say that the price will be, and we expect that the price will be 50. So this is our first test. So the test asserts that a product must have a price. Let's execute test, and here we have the test fails. Let's now write the minimal code to make it pass. Let's create a model called price calculator, for example, and here I'm going to export a function called calculate price. It will have a price as a parameter, and it will return it like this. Let's now import the calculator and then the test pass. Here my function, I know that it will receive many parameters and I want to use named parameters in arguments for this function. So I am now on the refactoring phase. So what I will say is that I'm going to create a type called calculate price params. So it will be an object, and then it will receive a price for now as a parameter. Let's save it. Here the test doesn't pass, of course, because we didn't pass the right parameter, and now the test pass. Let's now move to the next test. So I'm going just to copy and paste the second rule here. So any product can be discountable by a percentage. So I'm going to imagine that we have a discount percentage here, which would be 10%, for example, and we have here a price for 100%. So 10% on 100%, it will be 90 bucks now. So let's execute the code. The code doesn't pass. Let's now write the minimal code to make it pass. Let's go to the function. Here I'm going to say that the function will receive a discount percentage parameter. It will be optional because not all products have this discount. And then I'm going to destructor it here. And what I will see is that if discount percentage exists, what I'm going to say is that the price will be calculated like this. Let's save the function, and now as you see the test pass and all the previous tests pass also. What I can see here is that I have a calculation in a global function. Maybe I can apply the first rule of the SALT principle, which is a single responsibility principle. So what I can say is that I can extract this in another function. So is calculate discount, and here as you see I have now a function that will calculate discounts for me, and the calculate price will be the main function of this model. So let's save it, and as you see here our refactoring phase is successfully passed, and we have all the tests that pass. Let's now write the test for the third rule. So subscribers have 20% discount on all products. So what I'm going to imagine is that our function calculate price will have a boolean called is subscriber, which will be a true, and then I'm not going to pass the discount percentage here. 20% for 100 bucks, it will be 80 bucks. So here, let's save. Let's make the test fail, and then we will make it here pass. And all the test passes. Let's now refactor. I am not very happy with this magic number here, so I'm going to say that I'm going to create a const which would be called subscribers discount percentage, and I'm going to put it. Let's save the function, and we see that all the tests pass. This is great. Let's now write a test for our fourth rule. Let's copy and paste it. So this rule says that discounts are not cumulative. So if we pass discount percentage like this and a subscriber, so here according to our rules it will be 20% for subscribers, 10% of free discount. So here we have 30%. The rules say that this is not cumulative, so I will say that the price will be not $70. So if I save, I see that my tests pass, which is great, and I don't need to add any code in this, because the way that my function works is that it's exclusive for subscribers and discounts in the same time. So I will just pass to the final rule here, which is only the highest discount is applicable. So I'm gonna copy and paste. Let's save it, and we see that the test fails. So we have to do some adjustment to our functions. So here's the test pass. What we can do here as improvement and refactoring is that maybe I can say that I will make this function independent. So I'm going to refactor this. So as you see, I can save, and my code works perfectly. I hope that you liked this video. See you in the next ones. Ciao.